So today we're talking about polyatomic ions. You'll remember that an ion is an atom that has lost an element or gained or lost an electron or gained an electron, and therefore either has a positive or a negative charge. So we're going to be able to write formulas and name polyatomic compounds when you're done. Tell me, what does the word prefix poly mean? Not necessarily, but you're on the right, definitely on the right track.
More than one.
More than one.
Are you serious?
Yeah. Poly means more than one.
Oh, yeah. Nice.
So polyatomic would mean more than one. Polyatomic, more than one atom. So it's an ion that has more than one atom. What's going on here? Okay. So I don't know how much you guys have to write in. Probably a little bit. A polyatomic ion is a group of atoms that tend to stick together and have an ionic charge. They're like a gang of atoms. Okay? You don't want them in your neighborhood. Are you positive that you don't want them? They can be a negative influence, Logan. No, you're going away for a whole week. We'll send you a joke of the day when you're away.
Hey, absolutely.
Yeah. Maybe you can FaceTime us in or something or other. Where are you going again? Oh. Okay, bueno. Polyatomic ion is a group of atoms, a gang of atoms that tend to stick together and have an ionic charge. Do you guys need to write this down at all?
I got it.
Oh, you got it? Okay. They are often negatively charged, so most of the time they are negative, but there are a couple of positive ones. Here is the list. And I think you have it right in front of you, right? Okay, so nitrate, not to be confused with nitride, right? Nitride would be just nitrogen. Nitrate, NO3, and it has a charge of 1 negative. Hydroxide, OH, not to be confused with hydride. It's a 1 negative. Bicarbonate or hydrogen carbonate, HCO3. Sodium bicarbonate, baking soda, that you all made volcanoes out of in grade 3. Remember that? You guys never did that? The teachers didn't let you do that because it was too dangerous.
I didn't put it on the table.
Probably.
I was Catholic school, so I don't imagine it.
I'm not going there. You put your vinegar and your sodium bicarbonate, your baking soda, and it creates that sort of, You've never seen it before?
Oh, what?
No? All right. Well, maybe. So HCO3, that's bicarbonate. Chlorate is ClO3. They're all 1 negative. Carbonate, not to be confused with carbonara, which is yummy pasta. Carbonate, CO3. Sulfate, not to be confused with sulfide, SO4. It's a 2 negative. And phosphate, not to be confused with phosphide, is a PO4. Okay, so once they sort of do this, all the other rules are sort of the same. So basically, you're going to treat these as another element that forms a negative charge. So it's really just more stuff to add over here on the right-hand side. Okay? But they are gangs, groups of elements. And they're called polyatomic ions. Okay? Okay, so let's write some formulas. Sodium sulfate. If I give you the name sodium sulfate, how do you write the formula? Well, we know that sodium is a what group? What's the valence? +1. Sodium is a +1. Right? Sodium has a charge of 1 plus. Sulfate, from our list, sulfate is a 2 negative, right? SO4. Do I expect you to memorize those things on the list? No way, I am not an ogre. You will get that. I will give to you before the test, I'll give to you a periodic table that you can sort of prepare for the test. Okay, it'll have all the stuff, all the charts, all the things.
So in the middle there, where it's like from like the SC, like on the other side.
Yeah.
SC.
Oh yeah, sorry.
Yeah, that is like ZS.
Yeah.
I could tell if it's negative and positive.
All of these ones have those. They're like those, like lead and tin. Those ones that list I gave you the other day with the +2 or +3. So some periodic tables, actually, I found one online, will show all the charges on there as well. So all these guys act like that, but we just pick a few to sort of using for example. So you're only going to see like iron and lead. I don't know why I picked these ones. There's certain copper's a common one. Yeah. So I'm not going to give you one that I haven't given you a list for. Okay? And if I do, then I'll just change it. Okay, that's a good question. Okay, so we got Na is a +1, SO4 is a -2. So what's the formula going to be? Right? So remember how we did this crisscross thing? So Na, 1 positive, SO4, 2 negative. So remember we did this. Hello, Jesse.
Sorry,
That's okay, man. Well, it's not okay, but
it's not okay, I know.
yeah. Glad you're here. Right? And so what do? You do that crossover thing, right? Or if you want, we could, if you want to make SO4, do you want to do that? Do you want to make little thingies? Do that? No? No, you don't want to do that?
That's way too.
Okay, so then we're going to cross over, and what's our formula going to be?
And
The 2 comes down, the 1 goes there, and you get Na2SO4.
or
Yeah, now, whoa, Mr. Bennett, where'd the 4 come from? Well, because it's SO4 and the charge is 1, right? So you've got 1 SO4. If you want, some of them will put it in brackets, but usually we don't do that when the subscript is a 1. Okay, so you don't necessarily need that. SO4. Does that make sense? Jesse, I'm going to give you the sheet right over here. Yeah? Should we try another one? We probably should. Do you have it there? Sodium bicarbonate. That's the baking powder, baking soda. What it does is they put it in baking cupcakes and muffins and cakes. It's in there to produce hydrogen gas because it mixes with acids and it creates hydrogen gas and it creates the bubbles and makes your cake nice, soft, and fluffy. So sodium bicarbonate. So once again, the sodium is a 1 positive, right? From our periodic table. Sodium is a 1 positive. Bicarbonate, we're going to have to go back to our list. Bicarbonate is a -1. Oh, this is going to be nice because they match up. Right, so sodium's a -1. So when I do the crisscross, Na, HCO3, this is a 1 positive, this is a 1 negative. When you crisscross them, they're both 1s, right? So you don't need to write it, so it's just going to be NaHCO3. NaHCO3, sodium bicarbonate. How do you think? 5 seconds. Calcium is a 2 positive. Column 2. Chlorate is a, I got to go back. Chlorate is a -1. Chlorate's a -1, okay? ClO3, oh, I screwed up here. This should be what? Should be like that. Right? So when you crisscross them, Ca, ClO3, 2 positive, 1 negative, cross. Now, what does this mean, this ClO3, 2? How are we going to, that means 2 ClO3s. 2 ClO3s. So we're going to write it like that. Did you get that? You got to put the brackets. Okay? Because you have 2 of them, And because you got that 3, you don't want it to look like ClO32. Okay, you can't have that.
So what if you put in brackets kind of two?
That's not the proper way to do it, right? So it's 2ClO3. So really, in fact, you know what? I think you should draw this. Can we draw this? Can we go Ca, and we're just going to put some like dashes. We're going to ClO3 and ClO3. Can we just show that so that you can see? I want you to get that visual that there's 2 ClO3s. Remember, they're like a gang. They hang together. Got to keep an eye on those polyatomic gangs. Did you get that one, Logan? I slipped it in there. Got to keep your eye on those guys. Not even Chloe's laughing. I'm very disappointed. Or it just was that bad. Who's ClO3? Okay. Now, naming naming polyatomic compounds is super easy. Super easy. Not just regular easy, but new and improved, super easy. You write the name of the metal. Do you guys have to write any of this down? You write the name of the metal. You write the name of the polyatomic ion from the chart. And that's it. That's it, Ruben. That's how easy it is. Okay, so there's the chart again for easy reference. So if I tell you lithium, if I tell you Li2CO3, Li2CO3, well, that would be lithium CO3, CO3, carbonate, right? Lithium carbonate. Right? Easy there, Tiffany? Yeah? So, OH3. Oh, now hold on here. What do I do with the 3? Do I have to like say there's 3 OHs? Do I have to say like tri or OH3 or something like that? Nope, you just write the name of the metal and write the name of the polyatomic ion. So in other words, aluminum hydroxide. That's all you got to do. See, I told you it was super easy. Is there one more?
Yeah.
You try it. You try it. The last one is FeClO3. So ClO3 is chlorate, right? So it's going to be iron chlorate. Now, if I'm not mistaken, I think I made a mistake here. Because iron is one of these guys, and I think I have made a mistake. Iron is one of these. That means you got to use one of the Roman numerals. Iron, I believe, go back to your list. Is it a 2 or a 3, or a 1 and a 2? 2 and a 3, I think. 2 and a 3? Okay, so iron is a 2 and a 3. So in other words, yes, that's the point of this one, Mr. Bennett. Why did you screw this up? This is terrible. If ClO3 is 1 negative, ClO3 is a 1 negative, then that means, oh, and you know what else I screwed up on? Should there be brackets here? This is terrible. Very disappointed in myself. Yeah, I would get a fail today. That should be like that. ClO3. And not only that, so this is a 1 negative, and iron is a what? Must be a 1 or a 2. Is it a 1 or a 2? I do apologize. That's terrible. Terrible teaching. FeClO3. So that means that I actually have 3 negatives, right? So that means 3 ClO3s, which means I have a total of 3 negatives. And Fe could be either a 2 or a 3, right? But how many Fe's do I have? I've only got one of them here. There's no number here, right? So this total here is a -3. So if I've only got one of them, it's going to have to be the Fe3, right? So this should be iron 3 chlorate. And I think that's what the Googler said. Iron 3 chlorate, right? can be used in water purification.
Really?
That's what it says. Iron 3 chloride. You know what? I think we should do one more of these kind of ones. I'm going to make one up. Hopefully I don't screw up.
Fe and
What's the name of PB bracket SO42? PbSO42. Are you ready to see it? Okay, so if you go back to your one from before, and again, I'll give you this list on the test. You won't have to memorize this. Okay, I'll give you and I'll give you that periodic table ahead of time. By the way, we're probably coming up on the test. I got to do covalent bonding, and then we'll probably have a test. So like, I'm thinking like,
you should give us 2 days to study.
whoo.
1 day.
Okay.
Like during
So
class.
I'm thinking like about the middle of next week or so. Okay? Ish. Okay, so lead is a 2 or a 4, right? Those are the possibilities? Okay?
I think it's a 2.
Okay, so I'm just going to write PB is a 2 or a 4. Now, SO4 is a no, I didn't. SO4 is a 2 negative, but I've got how many SO4s? 2 of them. SO4, 2. So I've got SO4, SO4, 2 negative, 2 negative. So I've got a total of 4 negatives. So I got to have 4 positives. How many PBs do I have? I just have 1. So to have 4 positive, it's going to have to be lead 4. So this would be lead 4 sulfate. Some of those are pretty tricky. Lead 4 sulfate. Lead 4 carbonate. Try that one. Okay, lead 4 carbonate. Lead 4 means that it's a charge of 4 positive. Carbonate is a charge of 2 negative. Carbonate, 2 negative. So to make them balance out, right, you're going to have the lead, Pb 4 positive. And you're going to have carbonate, CO3, 2 negative. Crisscross them. So it's going to, now what happens when you got a 2 and a 4? Do you need, like, would you write Pb2CO3 4? Or is it kind of like fractions where you can reduce? It's like fractions where you can reduce. So I don't need the 2 and the 4. It, in fact, becomes a 1 and a 2. So your formula is going to be, the Pb2CO3 4 can be reduced down to PbCO3 2. Right?